thank you. And thank you, Linton, for the introduction. So I'm going to talk about the coastal environment of Trinidad and Tobago. So I'm not too sure if my slide changed. Did you see? Has it changed? Yeah. So just a little context in terms of where we are, and of course, where we are would influence the type of flora and fauna that exists here in Trinidad and Tobago, and our size. And based on our small size, we have a lot of coastline. So in Trinidad, we have 420 kilometers of coastline, and Tobago, which is much smaller, we have 120 kilometer coastline. Also, within our jurisdiction, that is within our exclusive economic zone, we have 77,502 square kilometers of ocean. And this gives us a ratio of about 15:1 in terms of sea to land. So basically, we have 15 times more sea than we have land. So that, of course, is important with regards to our development, economic development in particular. And then our population is increasing. The rate of increase has decreased, but however, the population increase has been increasing. Now, in terms of this speaking about our built environment, our natural environment, we have to look at our built environment. And because most of our development has been coastal, right? As you can see here, this was the latest land use map that I have for Trinidad and Tobago. I think it was 2009, and it's from TCPD. And based on the map, the pink areas are the urbanization, and then the sort of lighter pink and the brighter pink is commercial and industrial. And you would see that most of the development in Trinidad is along our west coast. And in Tobago, a lot of the development, again, is along the coast, because, of course, the bigger inland area is forests, right? Trinidad and Tobago haven't put into a report about 50% forest now. And most of the development in Tobago is within the southwest side of the island. So just to give you a little context in terms of our coastal area, 70% of our population resides in our coastal area. We're never too far from the coast. 80% of industrial activity of strategic national importance are also located along our coast. 60% of all small-scale economic activity that is significant to support human lives are located there. 80% of urbanized land, 50% of the country's national transportation artery, and approximately 90% of the tourist facility and hotel room in the country are located along our coast. So again, give you an idea of how much activities occurring on our coast, and of course that will compete with the natural environment. So in terms of the natural environment, here you have a map that was redrawn by IME in 1985 that gives you an idea of the type of coastal classification from cliffs, rocky cliff, low cliff, plain, urban, coast, wetlands, and mudflats. So it gives a kind of a classification of along our coastline. And similarly here in Tobago, again, different coastline status we have here in terms of exposed steep rocky cliffs, to fine graded sandy beach, mixed sand and gravel beaches, sheltered rocky coast, and then of course our sheltered estuarine marsh and mangroves, which is the lighter green you see this in the southwest. So based on that, our coastal ecosystem is quite varied and comprises rocky shores or cliffs, sandy beaches, coastal thicket or coastal vegetation, including littoral woodland, mangrove forests, seagrass beds, or coral reefs, right? And first of all, I'll speak about our beaches. We have a number of beaches in particular around Trinidad and Tobago listed here. We do monitoring of the ones that have the red dots. And of course, our beaches are important to us for many reasons. One, of course, is our tourism product, especially in Tobago, but it's also a place where we recreate. So it's important for us as for our own human well-being as citizens on the islands that we utilize the beach for recreation. The beach is also important in terms of habitat and space, especially for things like our nesting turtles, the leatherback turtles, and of course there's an associated ecotourism industry there, right? And but with all that said, our coast is changing, our coastline is changing, and I just want to give you an idea of what is happening with regards to our coastline. So this here is actually at Columbus Bay on our south coast, and most persons are familiar with the erosion that has been occurring in that area for many, many years. I think since Columbus was here, there was evidence that there was some erosion occurring out there in Columbus Bay. Just an idea of how things have changed. We would have had aerial photography for 1994 and 2014. That's the most recent aerial photography we have for Trinidad and Tobago. And the government would have also purchased ICONOS high resolution ICONOS imagery back in 2007. And we would have used this to look at some of the coastline changes that have occurred. And this is just an example of Caucus Area. And you would see how the coastline has changed from 1994 to 2014, the pink being 2014. So it's receding. Similarly, in Columbus Bay, Coral Point, the point is no longer a point, it's now a bay, Coral Point, as you could see here from the photograph, from the imagery. And we have here erosion from 1994 to 2019. So between 1994 to 2007, the erosion rate was about 3.3 meters per year. And this increased to 12.7 meters per year from 2007 to 2014. However, it slowed a little bit and reducing to 5.83 meters per year between 2014 to 2019. So again, the erosion, of course, on the other side of there, we have the Punta Arenal, where we have evidence of accretion occurring. Our coastline has not only changed because of erosion and accretion, but also to reclamation. And this is an idea of reclamation and how the coastline has changed in Port of Spain, specifically in Vedas Bay by Mucurapo. You see the stadium and so on. And a lot of this area, a lot of this build development is on reclaimed land, just like most of a lot of Port of Spain. I don't know if you know, but Independence Square, what is now Brian Lara Promenade, used to be Marine Square. The shoreline was closer to there, and the East Dry River was diverted away from Port of Spain to expand the city, and there was a lot of reclamation that occurred. And this is just some more recent reclamation that would have occurred in the Mucurapo area, and you see some evidence of the mangrove forest that exists there now. Similarly, back in the 1980s, 1970s, over 500 hectares of mangroves were reclaimed when they built the Point Lisas industrial estate. Again, there was some diversion of the Hoover River and so on during that time. But what has happened since then to now, there's been a lot of accretion occurring. And you would see here the difference in 2014 shoreline, coastline, right? Which has expanded seaward. The whole central Gulf of Paria actually, while you're experiencing erosion in the southwest and some erosion in the north, the whole central Gulf of Paria is sort of silting up. There's a lot of sedimentation occurring. Now that itself has some impacts because we're seeing mangrove dieback, for instance, in Point Lisas. And a lot of it has to do with change in the hydrology, and it's also affected by the fact that the shoreline is growing out and the seawater is not coming as far in to the landward side. So there's that flushing is being impacted, but that is of course a natural process. Just in Tobago, this is just an idea of the changes in the coastline that is occurring. This is the Bonnecord Lagoon Pigeon Point area. The Bucca Reef is out there. And of course, this is an important marine, but the area is a marine protected area, but the beaches are also important for recreation and tourism. And again, they're experiencing a lot of coastal erosion in certain parts of Pigeon Point in particular. On this part that people would visit the beach. And there's work currently going on trying to look at solutions to address the pollution. And they're looking at possible nature-based solutions or hybrid solutions because of the sensitivity of the ecosystem there in that area. I just had this study we did in terms of inundation due to sea level rise in that same area. So you're seeing the Bonaccord Lagoon here, and you're seeing the two levels based on two, what we call RCP's projections, right? At 2.6, what the inundation would be, and if you reach our RCP 6, the level of the darker pink, that's how far the sea would be going back. So of course, there's going to be a lot of coastal inundation and coastal flooding in that area. Now, in terms of our mangrove forest, and I guess I would focus a lot on the mangrove forest because I've been studying mangrove forests in Trinidad and Tobago for a long time. Just last year, 2021, we published a book on mangrove forests of Trinidad and Tobago. And this is basically the coverage, mangrove forest coverage as of 2020. And this would be based on satellite imagery we would have used. And you would see here the changes in mangrove coverage in Trinidad between 1994 and 2020. And you would see an increase in mangrove coverage between 1994 and 2007. And you're probably wondering, that's great, right? Unfortunately, the increase in mangrove coverage has been at the demise of some freshwater and marsh environments. And that is quite troubling. And I'll go into it in a little more detail. The more recent decrease from 2014, from 2007 to 2014, of course, has to do with a lot of built development and encroachment in mangrove areas and some areas where we're experiencing a lot of mangrove dieback. Tobago, again, we've had a first an increase, and then between 2014 to 2020 again, a slight increase in mangrove forests because you're having basically mangrove growing further inland as you have sea level rise and salt water intruding further inland. So you do have an extension of some of the mangrove areas landward. Now, the biggest mangrove forest we have in Trinidad, of course, is the Caroni Swamp. And it's also the largest wetland on our west coast, and the second largest after the River Swamp. Of course, it's an estuarine system, and it's comprised of primarily mangrove and marsh, interrupted by numerous channels and saline and brackish lagoons. And in 2020, the mangrove coverage was 4,155 hectares. Of course, this is, again, one of our most diverse ecosystems in terms of birds and so forth. And it's a very popular bird watching area, and it's a habitat for our scarlet ibis, which is the national bird and now an environmentally sensitive species. Now, we did some land use change analysis in for Caroni Swamp in particular, like from 1942, the first map is 1942, then 1957, 1994, 2003, and the last one is 2007. Now, back in the 1920s, when we were still a colony, there was something that was done to the Caroni Swamp. There was a plan called the Cipriani scheme, and the intention then was to manipulate, of course, the hydrology and create freshwater habitat to plant rice. So it was all about planting rice. But as time passed by, and of course, we didn't maintain the sluice gates and so forth to keep the salt water out, you've had the mangroves extending landward. And this is basically what you're seeing. Is the light brown was what was marsh areas. And as you look from 1942 onward to 2007, you would see the dark green expanding further, almost up to the highway. And this is the north-south highway. So you would see mangrove growing, increasing in size, but at the demise of the marshland, the freshwater marshlands, right? And of course, the red is the built development. The brightish green is agriculture. Now, of course, that is of concern. For instance, for loss of biodiversity, in particular freshwater biodiversity, also to even in terms of the scarlet ibises, because what they're noticing is that the scarlet ibises are roosting closer to the highway, because the young scarlet ibis requires freshwater invertebrates for food. So you find more scarlet ibis, which nesting closer to the highway, which is of course a cause for concern. Now, in terms of what is leading to this expansion in the mangrove, a number of things we suspect, including hydrological alteration. So this system has been altered over the years for many different reasons. Initially to facilitate agriculture, but then after we would have altered to facilitate build development and expansion and so forth, of build development, housing development and so forth. So the river has been straightened, it has been widened. The embankments have been raised, so much so that most of the water that comes in the Caroni River is flow straight out into the Gulf of Paria and doesn't necessarily flush the Guadino Swamp, right? And so you've had hydrological restoration. You also had where conduits were constructed to drain the land for other purposes, and those same conduits are now where you have salt water coming in. You have salt water coming in again. We're looking at things like sea level rise, and also too, you have a lot of a decrease in the amount of fresh water actually coming into the system because fresh water is harvested upstream. And also too, you have, it's projected that there would be droughts or decrease in the amount of fresh water outflow. So less fresh water coming in, more salt water coming up. And my colleague Hamish did a model here in terms of projected sea level rise for the Caroni Swamp, and this is 2050 and 2100. And this is for the RCP6. And this is what basically is going to happen in years to come if, you know, something, I don't know what we can actually do, but you will see the level of inundation that is projected to occur. Now, similarly, Guadino Swamp is another swamp. We call it the Guadino Swamp. Some people refer to it as the South Araput Swamp. It's the one by the Mosquito Creek. And this is the second largest wetland on our west coast. And it is primarily a marsh, freshwater marsh wetland, which is mangrove to the front. And this wetland itself has also been manipulated over time for a number of reasons. One is for oil and gas exploration. So of course, embankments were built and sluice gates were installed to keep out salt water to protect the installation. And then with that happening, there was opportunity for agriculture. So you had rice cultivation occurring in this wetland. And this eventually, of course, things were not maintained. The embankment broke, salt water intruded in. So they stopped and then it wasn't economically feasible, I think, for rice cultivation. So that stopped, and that wetland too the land use within that wetland has changed. A lot of the agriculture land that was former rice land is now what we call wet pastures, where it's kind of marshy area that is used for cattle and and other animals feeding. And again, you would see the red being built development within the Guadino Swamp. So you have an increase in build development, a decrease in, well, definitely very little or no rice cultivation occurring in there. The agriculture has decreased. You have more short crop agriculture as opposed to rice that was there previously. Now, another area that I thought was of interest is the Caucus Area. And I know most people, especially bird watchers, would have loved this area because you had these large open freshwater area that a lot of ducks and birds and so forth, migratory species, would have come in. But here again, you're seeing where these freshwater areas are actually being colonized now by mangroves, right? And again, we are losing that freshwater biodiversity. Now, of course, this is accompanied by the erosion that's occurring in Columbus Bay, right? As I mentioned before, the coral point is no longer a point, is now sort of like a bay. And you've had continual erosion, and with that, you've had salt water coming in further and further and extending into freshwater areas. And now you're seeing, first you see the fern, the mangrove fern, and then you're seeing a lot of the the mangroves, young mangroves and so forth growing in areas that were previously freshwater communities. Now, with regards to our seagrass community, back in 2002, IMA began an inventory of seagrass beds around Trinidad and Tobago. And this here is what we found back then, right? A lot of our most dense Thalassia beds were right here in Chagaramas, where we're located in Williams Bay. And you had three of the three seagrass species, that the Thalassia, which forms, or the turtle grass that forms the climax community, the haloduli and the halophilia. Those are more colonizer communities. And even back in 2008, IMA would have done surveys of the seagrass beds, ventral surveys, and there was a diversity of organisms we found there, you know, from crabs and sand dollars and starfishes, and we even have a seahorse that we would have picked up out there in those seagrass beds, right? And in Tobago, of course, we had dense seagrass beds in the southwest, and in particular the Bonaccord Lagoon, where you had mangrove seagrasses and coral reef, a contiguous ecosystem comprising of those three. In the Bonaccord Lagoon, in Kilgwin Lagoon, and in Pichitrue Lagoon, you had those things existing. So we had the most dense Thalassia beds. Unfortunately, we have lost all our Thalassia dominated beds in Trinidad and Tobago. We have
Dr. Juman, can I disturb you for 1 minute? Can you maximize your screen? Can you use slideshow so that we can follow?
Sorry.
Thank you.
Okay. I thought, sorry about that. So yeah, this gives you an idea of what existed back in 2002, 2003. The Thalassia would be in the climax, the turtle grass being the climax community, and then the other species. We found Syringonium only in Tobago, right? In Galaford, that area there, and in Canoe Bay. So we had dense seagrass beds in those areas seen in the map. However, since 2016, we've lost most of our dense Thalassia dominated beds in Trinidad and Tobago. We have small patches now that exist in Chagaramas, very small patches. We do have some very sparse communities with the haloduli and the halophilia, but they don't, they're not as utilized by species the way the Thalassia beds were colonized by and utilized by a number of species, including a number of species of juvenile fish. Similarly in Tobago, in the Kilgwin and Algarra area, the sites we monitored, we lost those beds back in 2015, and that was that coincided with the Sargassum event. So after that Sargassum event, we had basically lost a lot of we lost the Thalassia beds. Now we're seeing some regrowth, and we continue to monitor to see if there would be some recovery. However, right now in Trinidad and Tobago, the only extensive Thalassia bed that exists is in the Bonaccord Lagoon, and those beds are doing well because I guess the nutrients to some extent is providing some help, and they're now expanding further out into the Nyland Pool and into the Pigeon Point area. Of course, there's a lot of concerns about the grass beds in the Nyland Pool because the tour operators, they don't find it very appealing to take folks out there to utilize that area for bathing and so forth. So this is just an idea of the seagrass communities that exist in Trinidad. And then our coral reefs. So in Tobago, we have a number of fringing coral reef around the island, and that's shown there in the pink. We have been monitoring coral reef at the IMA for a while, and in 2010, right, there was a massive coral bleaching event that occurred, right? So that has, since that coral bleaching event back in 2010, there's been no recovery in the following 10 years, and the average coral cover is approximately 14% among all the sites that we monitor, with some reef as low as 5% coral cover. Most of the coral communities have undergone a shift in benthic dominance from corals to algal dominant reef, right? over the last 10 years. At some sites, we have the turf algae that make up nearly half of the benthic cover. And these include reefs like Culloden, Western Reef, and Plymouth Reef, while at other sites, sponges, and that is like blackjack hole in Speyside, and octocorals in like Castora and Culloden geese. They make up a significant portion of the reef. So we are seeing where our coral-dominated reefs are no longer coral-dominated. They're very much impacted by not only the coral bleaching event, because we're providing data here from that bleaching event occurring, but even before that, we would have experienced a shift in terms of coral dominance to more turf algae and algae also coral dominance. So our ecosystem, our coastal ecosystems are changing, and we expect that they would continue to change because of all the both conditions that are national to some extent, things that we do, but also too because of global climate change and the impacts of global climate change on our coastal environment. So thank you for your attention, and I'm open for any questions you may have. Thank you.